Hello everyone, this is Philipp Jonas for Kalamazoo Valley Community College, and today we're going to talk about the costs of production. So this is our first lecture dealing with the economics of business decision making. And we're going to start out today with discussing how we think about a business in economics to begin with, and many fundamental principles about its costs. In the next 4 lectures, we will take these principles and derive the standard business decision-making rules of economics. But first, let's start with a basic assumption. What's the objective of the business to begin with? In our course, we're going to assume that it is the business objective to maximize its profit. Not exactly a controversial assumption, but of course you can start businesses for other reasons as well. So when we talk about profit, we mean the difference between the revenue of a business and its costs. Revenue is a very straightforward concept that we already encountered in our lecture on elasticity. It's the amount of money your business receives from its customers, often referred to as the business's sales or turnover. But let's have a closer look at the cost of the business, which is our main topic today. So already when you have a look at that definition, you will notice something that is special in economics. When it comes to cataloging the costs of our business, we are valuing the inputs that our business uses using their market value. So that's not necessarily what you're actually paying for that resource, but its market value. The best example of this is that there are some resources that have value even though you're not paying for them. Let me introduce you to some standard terminology for this. So many things that our business uses, we do of course have to cut a check for. Those costs are referred to as explicit. If we were to think of you as a business and your decision to go to college as a decision that has to be made, some of the explicit cost of college would include tuition or books. Those require a direct cash outlay. But what about the implicit cost? One of the most expensive aspects of going to college, probably the most expensive for most of you, is the fact that you have to use a lot of time in order to attend college, do your studying, take your exams, and your time has a market value. For example, we could look at what your hourly wage would have been if you had gone to work instead. That cost is real from a decision-making standpoint. So that's what we're concerned with in economics, even though you're not writing a check for it. So in economics, when we talk about profit, almost always we refer to so-called economic profit, where we're taking the revenues of a decision and subtracting both explicit and implicit cost. Both of those together are also referred to as opportunity cost. While most of the time, if you look at an accounting statement, it's based more on the financial condition of a firm. So that statement is more likely to only list explicit cost. Of course, accounting is also capable of adopting this opportunity cost framework. And if they do so, this approach is referred to as economic accounting. So with that first introduction out of the way, let's talk about how we think about a business now. Step number 1, what we call a production function. The first step to successfully analyze a business is to be able to describe how it operates to begin with. This description is called a production function, and it lists all the inputs your business might use in order to construct output. There are different ways in which you can set up such a production function. You could have a big spreadsheet in Excel, you could write a formula that describes it, maybe you can draw a graph that describes it. Of course, for our purposes, we'll stick to very simple production functions that only have 1 or 2 inputs. In an actual engineering context, life is not going to be that easy. For example, think about the production function of making a car. There are thousands of discrete items that go into that vehicle, in addition to the machinery and labor that's needed to assemble it. But here's the example we'll be working with for the next couple of minutes. Let's talk about Farmer Jack. He grows wheat, and we'll assume that it only requires 2 things to grow wheat. Number 1, land, of which he has 5 acres, and number 2, employees, which he can hire as many of as he wants on a monthly basis. So if you were to analyze Farmer Jack's business, you might be able to list his production function as a simple table or graph. Let's have a look at this. So the table here on the left, we're going to list how many employees result in how much output. That's because the land is fixed, we don't have to list it. Or if we were to draw this as a graph, we'll put the input, the employees, on the x-axis and the output on the y-axis. So you spend some time with Farmer Jack's farm, and here is what you've learned. For starters, if he has no employees, obviously he grows no wheat. And then his farm can support up to 5 employees. If he has 1 employee, the farm produces 1,000 bushels of wheat. With 2 employees, 1,800 bushels, and so on and so forth, until it's maxed out with 5 employees producing 3,000 bushels of wheat. Over on the right, you'll notice the same set of numbers reflected on the graph. Of course, typically on the graph, after we're done drawing those dots, we'll then go ahead and connect them to make the thing a little easier to look at visually. And of course, right away something sticks out to us. Farmer Jack's production function is not a straight line. Adding additional workers adds less and less additional output to our farm. This is very common in business. Typically, businesses have some factors that are fixed, at least for a while. So for example, Farmer Jack, he has 5 acres to work with. We can throw more employees at those 5 acres and that will raise production, but there's a limit to what you can squeeze out of that land. So if a business has such a fixed factor of production, increasing the variable factors of production will add less and less to output. Now, when it comes to running this farm efficiently, describing that phenomenon is going to be quite important. So let me tell you how we think about it. In order to describe the productivity of our inputs, we think at the margin. So this is a concept we first encountered when we talked about consumer and producer surplus. The margin is the idea that we're thinking about a process stepwise, one increment at a time. So for example, we can look at Jack's farm and ask ourselves, how much does production increase for every additional worker he hires? In general, you can calculate the marginal product for any input of your business. Again, it's the change in the output of your business for every additional change in input. So let's write this up mathematically. You're probably familiar with the notation of the Greek uppercase delta to denote the change in a variable, even if maybe you haven't used that in a while. So when we look at Jack's workers, here's what we're trying to describe. How does the output change? So what's the delta in Q? Versus how does the input change, the delta in L. Or specifically, we're going to calculate his marginal product as the change in output divided by the change in input. So let's go back to Jack's production function, the table version. I'll have something to say about the graph in just a minute, and work out those numbers. Here are the 0 through 5 workers and the output they produce. So let's go ahead and calculate the marginal product of hiring the first worker. That's probably the easiest one to work out. So for the first worker, production goes from 0 to 1,000. The change then is 1,000. And the change in workers is 1 additional worker. 1,000 divided by 1. The marginal product of the first worker is 1,000 bushels of wheat. But now let's look at how the math works for the second worker. We are looking at changes here. So let's focus on how much output changes going from 1 to 2 workers. The output change is 800 units. The input change is 1 additional worker. That means the marginal product of the second worker is 800 bushels. Really make sure to pay attention to the change notation here. even though marginal product is a measure that's per worker, the second worker adds 800 units of output, it's not an average, and you're very used to doing averages. If we wanted to calculate the average production of 2 employees, we would take the total output, 1800, and divide it by the total labor force, 2. But with the marginal product, we're focusing on changes instead. So let's do that for the rest of the table. Every row obviously represents 1 additional worker, so we're always dividing by 1. But each additional worker adds less and less to output. The third one adds 600, the fourth one 400, and the final and fifth one 200 additional bushels of wheat. This is not because the workers are worse, that the fifth worker perhaps doesn't work as hard as the first one. This is because we have more and more workers working the same fixed resource, 5 acres of land. So we're treating the workers here as identical. Nevertheless, the additional contribution of each worker diminishes. Now let's have a look at the same phenomenon when we look at the graph of the production function. And there, this change over change calculation will equal something you're very familiar with: the slope of that production function. Remember how that production function graph flattened out? The slope diminished? That's because the production function rose, delta Q, less and less for every additional run, delta L. Here's the graph to demonstrate this. The first worker raises the production function by 1000 for a run of 1, the second by 800 for a run of 1, and so on and so forth. So dividing 2 changes by one another might actually be more familiar to you than you remember, because a slope is an example of dividing 2 changes by one another. So this is step 1 of analyzing a business, establishing its production function. Step 2, we now convert this production function into cost. So each input that the farm uses, we're going to attach a market value to. Let's say the land has a market value of $1,000. Let's say we know that because Jack is leasing that land for $1,000 a month. And the workers, each of them is paid $2,000 per month. We then go back to the production function and add the cost of each resource into additional columns. So here we are again with Farmer Jack's production function. 0 to 5 workers, 0 to 3,000 bushels of production. So what about the cost of the land? Well, the land is always the same. 5 acres, $1,000 he's paying for it. So that's going to be $1,000 all the way down. Special note, notice the $1,000 also appears when Farmer Jack is producing no wheat. That's because when we set up a table like this, the 0 production row, often the first row of a production function, represents the business existing but not operating. This is called shut down. So Jack has his farm, he's leasing the land, but currently he's not growing any wheat. The cost of the land only disappears if Jack gets rid of it. That is referred to as exit in economics and typically is not represented on a production function. Alright, so that's the land. What about the labor? Well, the cost of labor will depend on how many workers we have. We take the worker count 0 through 5 and multiply it by $2,000 each, giving us payroll costs between $0 and $10,000. After you've attached the market values to all the inputs your business uses, and in real life that's going to be more than 2, in the very final column you sum across all those costs in order to get the total cost of producing the different amounts of output that we might seek to do. For example, producing 2,400 bushels of wheat carries a total cost of $7,000. This total cost will form the basis for all additional perspectives on cost we will have in this lecture. So let me tell you a little bit about how we can describe the total cost of this business. For starters, we can of course draw a graph. So if we take the quantity versus the cost of production and graph it up, we notice that this graph features an increasing slope. That's because as Jack increases the production of his farm, it becomes more and more expensive to add additional bushels of output. This is of course the mirror image of the production function. If each additional worker contributes less and less output, it becomes more and more expensive to add additional output. Now, keeping a track of those escalating costs is going to be crucial for making good business decisions. So we should have a way to describe what's happening to our total cost curve. How do we do that? Well, this is economics, of course, so we're going to do it at the margin. Marginal cost, the first of 4 per unit cost concepts we will learn. And as far as I'm concerned, my personal favorite. It is a very useful perspective on cost. So marginal cost is a marginal concept. It answers the question, how much does my cost increase per every unit of increased production? So we're looking at changes again. Anytime you encounter a marginal in economics, you will have a delta divided by another delta. Look out for that. Marginal cost. Loosely speaking, it answers the following question. What does it cost me to grow 1 additional bushel of wheat? So let's go ahead and calculate that using the provided formula. Starting at the top of the table once again, if we hire our first worker, our cost increase, we're looking at a change, from 1 to 3,000. So that's $2,000 increase for 1,000 units of additional production. So taking a $2,000 cost increase, dividing it by 1,000 additional units, we get a per unit cost of $2. Increasing production from 0 to 1,000 units, hiring our first worker, means we have to pay $2 per bushel of wheat that we're adding to the output of our farm. Going from row 2 to 3. So now we are hiring our second worker. Again, that makes the cost increase $2,000. Every row on this table has its cost increase $2,000 because every row represents one more worker. But the marginal cost isn't staying constant because that second worker is adding only 800 units of additional output to our farm. So at this point, hiring the second worker, we're paying $2.50 per bushel we're adding. This keeps happening as we move down the table. Every additional worker costs $2,000, but adds less and less incremental output. Until we reach the very last worker, $2,000, but they only add 200 units to our output. That means hiring the fifth worker means we're paying $10 per bushel. We will learn in the next lecture that this perspective is critical to decide how much is worth producing. To give you a little foreshadowing there, we should only hire that fifth worker if we can sell the wheat for more than $10 a bushel. We'll get back to that. Now, we've had a lot of fun here talking about Farmer Jack, but I now need to move to a more sophisticated example with slightly more realistic numbers. That's because when it comes to the other per unit cost concepts, there are some standard shapes I want you to be familiar with. So let's do this again. Let's describe a generic business. You probably already caught on to what I was doing when it came to Farmer Jack. I specified 2 resources, one that was fixed and one that was variable, land and labor. In general, when constructing the costs of a business, you will find this division. There are resources whose costs are fixed. There are resources whose costs are variable. Adding them together gives you the total cost of the business. And you should always be able to do this, dividing the cost of a business into fixed and variable. This is important for some of the decisions it'll support. So if you have a cost and you think, well, it's fixed at first, but then it turns a little bit variable, that's not disaggregated enough yet. Divide that further until you have a component that doesn't change and one that does. So for my second business, we'll keep it very generic. This business can produce between 0 and 7, well, widgets. No matter how many it produces, its fixed cost is $100. Let me also graph that up for you to point out some standard features of these graphs. Anytime you graph the fixed cost of a business, it better look like that, a horizontal line since it's fixed. That includes quantity 0, the condition of shutdown. Fixed cost exists even during shutdown. Here are the variable costs of this business. So if you have a look at this set of numbers, you'll find they follow a more interesting pattern than what we had going on with Jack's firm, and there's a reason for that. For now, I just want to point out the following. Variable cost always start at 0. By definition, in shutdown, variable costs are 0, or in other words, all costs that exist in shutdown are fixed cost. So here are some useful implications of that. Number 1, when we look at the total cost of a business, you can break those apart into fixed and variable cost very easily. Look at the row that represents shutdown. Whatever cost you've got going on there, $100 in this example, that's all fixed cost, 0 variable cost. Once you have the fixed cost for one row, you have the fixed cost for all rows. And then you find variable cost as the difference between total and fixed. Or if we look at the graph, when graphing total cost, it starts at the same point as your fixed cost, but then parallels the shape of your variable cost curve. So these are the costs of our business in its totality. Total cost, or divided into its fixed or variable. We now have 4 standard ways to divide these costs into per unit cost. And each of them will be useful for us down the line to describe a particular type of business decision making. Let me start with my personal favorite. We've already encountered it. Marginal cost. Reminder, marginal cost is the change in total cost divided by the change in quantity. How much it costs to produce one more unit. You'll notice that typically for a business, marginal cost increases when you reach high levels of production. Like here. We saw the same with Farmer Jack when he was hiring more and more workers. But this example is a little bit more realistic because it's also quite common, not guaranteed, but quite common, that increasing from low levels of production, we see a brief decline in marginal cost before they start increasing. That's because many businesses need a certain minimum level of operation before they become efficient. So you actually see an increase in efficiency before it starts decreasing again. This very common shape of a marginal cost curve looks as follows. We have a decreasing section followed by an increasing section. So that's one of our per unit cost concepts. The other 3 all follow the same pattern. They're averages. And I bet you are really comfortable with averages. Averages mean you take whatever cost concept we're looking at and you divide it by the quantity produced. For example, average fixed cost, take your fixed cost of production and divide by the quantity produced. Have a look at the numbers this generates. There's a pattern here, right? In our first row that's calculable, we're taking our fixed cost and dividing by 1 unit. In the next row, we're taking that same fixed cost and dividing by 2 units. So the number gets smaller because the numerator stays constant while the denominator increases. This is something you should look out for when you graph average fixed cost. Average fixed cost always decreases, assuming there is fixed cost and it isn't at 0 across the board. Average fixed cost is also useful for us because it has to do with the scale of a business. If a business has very high fixed cost, it almost always needs to have high levels of production to spread that fixed cost out over many customers. For example, operating a mobile phone network in the United States is very expensive. You gotta have towers all over the country, a high fixed cost. That means in order to be competitive, assuming you own your own towers, you need to have a lot of customers for that to make sense. This explains why we only have a handful of companies that own their own towers, and all of them are huge. What else do we have? Well, you can apply the average concept to any of our cost. Average variable cost. Take the variable cost, divide by quantity. Always the same pattern for average. Take the cost concept, divide by quantity. Average variable cost isn't guaranteed to follow a certain pattern, but a U-shape is common. Average variable cost will be useful for us because it lets us know when to shut a business down. For example, imagine you own a touristy retail shop in a tourist town. Chances are this town has an on-season and an off-season, and during off-season business is going to be bad. You'll have to make the decision if it's worth it to stay open or not. As we learn in our next lecture, average variable cost holds the key to this important decision. Here's a picture of the average variable cost for our second example business. Notice the U-shape. Finally, we can apply the average principle to total cost as well. Take total cost, divide by quantity. But of course you can get to average total cost a second way. You can also take your average variable and average fixed cost, add them together, and arrive at the same number. That's because fixed and variable cost equal total cost, so if you divide everything by quantity, the equation still holds. This is useful for checking your own work. Imagine you've completed a cost table like the one you're looking at right now. At the end, you can pick yourself a row in your table, let's say 5 units of production, and calculate average total cost 2 ways. Take your total cost, 380, divided by 5, so that's 76. Or take your average fixed and average variable, 20 and 56, and they should add up to the same number. If they don't, something went wrong in your calculations. Average total cost. Graphing it up, it is also common for it to be U-shaped. Here's the average total cost for the business we're currently analyzing. So let me sum this up one more time. There are 4 standard ways in which we calculate per unit cost. The one we covered most recently is average total cost. Total cost divided by quantity. And then we learned about 2 other averages. Average variable and average fixed. When you spend more time with them, you will learn to recognize these curves, even if there's no legend. Imagine I drew these 3 lines for you and I asked you to identify which is which. Here's how you would approach that. Average fixed cost must always decrease. So if there's only one line that always decreases, that has to be average fixed cost. Another approach. Average total cost includes both other averages. So it has to be on top and cannot be crossed by the other 2 averages. And finally, average variable cost will more and more follow the shape of average total cost while lying below it. That's because the distance between average variable and average total is given by average fixed. So the smaller average fixed gets, the closer to each other average variable and average total will be. Those are our 3 averages. But we've got one more, right? Marginal cost. So when I first draw that in, it seems like it's all over the place. And it would be difficult to know which curve is marginal cost if you haven't got a legend. But when I look at this set of curves, marginal cost is actually the first one that would stick out to me. That's because it has many very useful properties. one of which I'm going to introduce you to right now. Marginal cost is related to the average total cost curve. Let me show you what I'm talking about. Here's the average total cost of this business. It's got the typical U shape. Let me remind you of what's going on here. At first, when you increase the production of your business, you can spread out your fixed cost over more and more units. That tends to decrease your average total cost. But once those fixed costs are nice and spread out, typically your business runs into diminishing returns, and the increasing average variable cost starts to dominate and bring your average total cost back up. That's why the U shape is so common. So imagine you look at this cost curve for a business that you own. A point that might be particularly interesting to you is the minimum of that curve. In our example, that happens at 5 units of production. That's the point where your per unit production cost, calculated on an average basis, is the lowest. In economics, we call that the efficient scale of your business. While we will learn in the next lecture that it's not always the best move to operate your business efficiently, meaning at the efficient scale of production, quite often it is. So that point is very interesting to us. So keep an eye on that efficient scale, 5 units. And now let me overlay the marginal cost of this business. Can you see it yet? They intersect, not exactly at 5, but suspiciously close. That's not an accident. Marginal cost affects average total cost. Marginal cost describes what does it cost me to produce an additional unit. What an additional unit costs you to produce will affect the average cost of your business. Let me show you. So imagine your business starts producing from 0 and increases production. Before we hit this intersection, so in the range indicated by the blue brace here, all the marginal cost points are below the average cost points. If you produce a unit that has a marginal cost less than your average so far, it will lower your average cost of production. Let's think about this in a context that you might be more familiar with. Imagine a class with an average grade. If I add a student that has a grade lower than the average drops. Production works in the same way. If I add a unit of output that has a cost below the average, it lowers the average. So this keeps happening with units 1, 2, 3, 4, and 5. Each of them lowers the average. But then we reach the other side of this intersection, now indicated by the blue brace. Here, the additional cost of each unit is higher than the average. Anytime you do that, produce a unit at above average cost, your average cost will rise. Again, think of a classroom. If we add a student with an above average grade to a class, the class average rises. So let's put these two concepts together. If we want to minimize the average cost of production, so in our example that would be 5 units, that's the lowest point, the efficient scale of average total cost. Here's how you can think about this on the margin. You produce every unit whose marginal cost is less than the average, because they'll make the average drop. So that's units 1 through 5. And then you will not produce any unit that has above average cost, units 6 and 7. That's why marginal cost intersects average total cost near or at average total cost curve's minimum. It's near if we're talking about production like this that's discrete, meaning 1 unit at a time, then you might not get the exact intersection. If, however, we were producing something that had a continuous number, some sort of smooth mathematical function, how much oil we're pumping, something like that, then the intersection will be exactly at the minimum. This will be useful to us. But for today, let's instead finish up talking about timeframes. When we develop our business decision rules in the remaining 4 lectures, we're going to do so over 2 different timeframes. Economists call them the short run and the long run. Here's the difference. In normal day-to-day business decision making, some aspects of your business are likely to be fixed. Like when Farmer Jack thinks about how many workers to hire, the amount of land that he has is fixed at 5 acres. Such a decision where something about your business is fixed, is called a short-run decision. Think about operating a retailer. You are in a certain location, you're not going to be able to change that very quickly. So for a while there, all your decisions are constrained by that fixed resource. But given enough time, of course, everything about a business is variable, including, for example, how much land Jack has. He could lease more or less. This gives additional opportunities for decision making, which means long-run decisions, where everything can be changed about the business, may have a result different from short-run decisions. We're going to illustrate that today using the example of an average total cost curve. We can draw average total cost curves for our business while some aspect of the business is fixed. That's called a short-run average total cost curve. Or while everything is possible. That's a long-run average total cost curve. Let me show you how to do that. So for our example, we will consider a business that can come in 3 different factory sizes: small, medium, and large. Let's say for each of these factory sizes, we have constructed the average total cost curve. Here's the one for the small factory in blue, for the medium factory in green, and for the large factory in purple. Notice which size factory you want to be in depends on how much you're producing. Like for example, if you're producing a low amount, then being in a small factory is actually more efficient than being in a medium-sized factory. But in the short run, you're trapped on one of these 3 curves. In the short run, the size of your factory is fixed. So if, for example, you're currently in the small factory, all short-run decisions will use the blue average total cost curve. But what about a long-run decision? What if we're considering something of a time frame where we could actually switch over into a medium or large size factory? Well, first of all, at what levels of production does that become interesting? This, of course, becomes interesting at the intersections of these curves. So, if I'm producing below quantity A, even though it's possible to do so in a medium-sized factory, it's cheaper to do so in a small-sized factory. So for that first range, it's always best to be on the blue curve. Between A and B, it's always best to be on the green curve, and beyond QB, always best to be on the purple curve. So in the long run, only sections of these curves are relevant to us. For each of these ranges, we choose the lowest possible average total cost. Or if we want to draw it as one curve, here represented in red, we trace along the bottom of each average total cost curve to get our relevant average total cost in the long run. Blue, green, and purple are short-run average total cost curves. Red, the minimum of all of them, is the long-run average total cost curve. Let's do that one more time. Let's say you've got a large number of factories you could have all over the world, and they each have their own average total cost curve. How would you describe the long-run average total cost of your business? Trace along the bottom of each curve, because in the long run, that will be your best curve to be on your lowest possible average total cost. And let's finish up with a word about this long-run average total cost. It's not guaranteed that it looks like this, but it's common. And the various aspects of this curve does have standard names in economics. Like, look at that first section. As we increase production from very low levels, we can transition into a business structure that lowers our cost. That's called having economies of scale. When producing more, lowers your long-run average total cost. And then for many businesses, there's a range of outputs where your average total costs are very comparable. That's called having constant returns to scale. Most businesses will be on this section of the long-run average total cost curve because it's most efficient. Finally, it is entirely possible, even common, for businesses to become too large to be efficient. This is called having diseconomies of scale. Typically that happens when any production efficiencies you could pick up from being even bigger get dwarfed by the additional complexity and bureaucracy of organizing a business. That's why in most industries, we don't have one business that serves the entire market. Instead, we have a number of businesses all operating on the constant returns to scale section of their long-run average total cost curve. In most industries. 2 lectures from today, we're going to discuss businesses where the average total cost curve always falls, and then that industry is going to become a monopoly. This concludes our first look at the cost of production. We're going to use the concepts we learned here in order to construct our fundamental business decision rules.